about this lesson is we've already learned something very similar to it last semester. So this is going to come really easy to us because we've already done something almost just like this, okay? So you got your whiteboard out. Why is this picture on here? Because it's a triangle and that's it? That's the only reason?
Because it's two of them.
Similar shapes.
Similar triangles? So this triangle on your dollar bill is similar to the whole triangle on your dollar bill. So that's why it's there. Similarity on your currency. Imagine that. All right. Everything we've studied so far, everything we've done, has depended on the fact that the triangles are similar. If the triangles aren't similar, everything we've done means nothing. You can't set up a proportion. You can't find a scale factor. You can't do any of that if your triangles are not similar. So today, what we're going to do is learn how to decide, wait a minute, are those triangles actually similar or are they not similar? What unit is this similar to? Oh, I didn't mean to say that word again, but what unit is this like from last semester? We're trying to prove these guilty of being similar. When did we do that before? The hypotenuse thingy.
Side and the side.
There you go. Do you remember that song, that annoying song?
Yes.
Side equals side.
No.
Hypotenuse leg, right? Okay, so we're doing that same thing, except we're proving them similar, not proving them congruent. So, what in the world do you think we need to check to prove these two guilty of being similar? First, okay, so we would need to rotate it, and what are we checking for?
To see if it fits into that one.
But it's not going to fit into it because these are similar, not congruent.
See if the angles. It doesn't.
Ooh, what do we know about similar figures? What do we know about their angles?
Their angles are
Their angles are the same. And what about their sides?
No.
They don't have to be.
Starts with a P.
Proportional.
Proportional. Angles are the same. Sides are proportional. So we're going to need to check that the angles are the same and that the sides are proportional. A costly mistake. Jasmine's in charge of drawing the construction documents for a church. Remembering what she learned about similarity in geometry, she made calculations for the measurements of the triangles shown, assuming the triangles were similar. During construction, the contractor calls her and yells at her for costing them hundreds of dollars due to purchasing incorrect lengths of wooden beams based on her triangles. Jasmine thought the triangles looked similar, but they weren't. How could she have checked to make sure they were similar?
Check her angles. Measure them.
Measure the angles? Okay. What if she doesn't have a giant protractor? Just saying. What if she doesn't have a protractor that's this big? What can she check?
The side.
Check the sides, and what would she do with those numbers she comes up with?
Make a proportion.
Make a proportion. Awesome answers. Love it. All right. What do you see here?
The angles are the same.
How many angles?
2.
2. Is that enough? If I know that 2 angles of this one match 2 angles of this one, what do I know about that third angle?
Nothing.
Scoring says nothing about the third angle. Could that third angle be anything it wants to?
They could be the same, or they could be different.
Okay.
I don't know.
No. Thank you for being involved in the lesson. Julius, give me a number between 0 and 90. 89. Well, that's actually not going to work. Give me a number between 0 and 80. 48. Okay. So, this angle's 48 degrees. What's that angle? Well, it has an arc, so it's got to be 48 as well. Brett, give me a number between 0 and 20. 18. Okay, we like our 8s today. So this one's 18, and it's got double arcs. So what's this one?
18.
What about that third angle?
It has to be the
It
same.
has to be the same. It has no choice, because what do angles of triangles add up to every time, always, no matter what? 180. Every time the angles add up to 180. So what is that third angle? I saw Ashley pressing buttons. What is it? 114. If it's 114 in this one, and then you add these and subtract from 180, it's 114 in this one. So what I'm trying to get across is that if you know 2 angles, you know all 3 angles. Okay, so this is our first postulate. You don't need to write it down anywhere, because thank goodness, last semester there were 5 postulates we had to learn. 5. This time there's only 3. So that's good news. All right, so the name of this postulate is angle angle, and then I say squiggly just for fun, but it really means similarity. Angle, angle, similarity. Okay? If you can find two angles are congruent to two angles, then you're done. Those triangles are similar. Let's move on. Now what is given? All three sides? Now, do sides act like angles? If we know two of them, do we know all three of the sides?
No.
Because there's no set number that sides add up to, right? There's a set number for angles. 180 is the set number, but there's no set number for sides. So be careful. If you know two sides, you do not know that third one, because that angle could change. Are these sides proportional? 2 is to 4 as 3 is to 6? Yes, no?
Yes.
2 times what is 4? 2 times 2 is 4. 3 times 2 is 6. Okay, so the sides are proportional, but I would say, nope, I cannot prove those guilty of being similar. But what if I give you all three sides? We don't know any of the angles, but we know all three sides. I think we're going to be okay, because remember those angles are related to the sides, the smallest angles across from the smallest side. So what would we call this one? The other one was called angle, angle, squiggly. What would we call this one? Side, 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 and you have to put the squiggly, or else you're proving them congruent. That means similar. So don't forget the squiggly, or Miss Stanton will mark it wrong, because you just said they were congruent if you don't put the squiggly. They're definitely similar, not congruent. Okay, last one, last postulate. We only have 3. This is great news.
This one's siding.
Nasia, what do you think? This one's called? Torin just said it. What do you think it's called? No, the last one was side, side. Look at the picture.
Side, angle.
Try again. Let's go in order. Let's go around like this.
Side, angle, side.
Yeah. And then what did we not forget to put afterward?
Squiggly.
Squiggly, and that means similarity. Okay? Side, angle, side, similarity. They are similar by side, angle, side, squiggly. Okay. Let's work on some examples. Now, just to let you know, when you're doing side, 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 and you're comparing the sides, you need to put the smallest over the smallest, the medium over the medium, and the largest over the largest. That makes sense, right? Put small over small and large over large. Oh, here's an example. Okay, everyone on your whiteboard. On your whiteboard, I want you to see if this triangle is similar to this triangle. I want you to put the smallest number over the smallest number, the medium number over the medium number, and the large number over the large number. Go. Write a proportion on your board right now.
Wait, what?
I want you to write
I gotta go.
a proportion. It should have 3 ratios in it. Small over small, medium over medium, large over large. Then I want you to divide them out and see if they are equal. Ava, tell me what proportions you got. 1 over 3. 5 over 15.
9 over 27.
Cool. That's the correct setup. Every time when you divide, let's see what do you get every time when you divide. Oh, you need to go get your calculator. Go get it right now. Here's your chance. Perfect timing. Shelby, what do you get every time? Come on, do it. 1 divided by 3. Okay, 0.3 repeating. If you did math enter, it would spit back 1/3 at you. What about 5 over 15? Anybody? It's 1/3. What about 9 over 27? It is 1/3. So are these guilty of being similar? Yes. And what are they guilty by? Side, 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 squiggly. All right. We already did that one. All right, so take a look at those triangles now in the costly mistake, Jasmine's costly mistake. It's hard to see those. So right now it looks like these are side, angle, side, side, angle, side. But let's compare the numbers. This, I know, 6.5, and this is 4. 6.5 is to 4 as 6.6 is to 4.1. Divide those out and see if you get the same number. 6.5 divided by 4. 6.6 divided by 4.1. Are they close though? When you divide them out, is it close? What decimal are we getting? 6.6 divided by 4, 1.62. 6.6 divided by 4.1, 1.61. So they're off by 100th of a point. They were so close to being similar, but they weren't similar. And that's why they got really mad at Jasmine for assuming what she wasn't supposed to assume. All right. For the rest of the examples, you're going to determine if they're similar. And if they are similar, we have to write one of those similarity statements, like we did last time. So determine if these two triangles are similar. Here's your choices. Angle, angle, squiggly. God bless you. Side, 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 squiggly. Side, angle, side, squiggly. And none. Those are your choices. Do it on your whiteboard. You need to write one of these 4 things on your whiteboard and you need to show it to me. First one, very good. Ken, second one, very good. Try again. Very good, very good, very good, very good. Very nice, thank you. Yep, yep, yep. Very good, very good. Torin, what's angle B?
Sorry, I
It's okay. 100. Wait, that's 100. 60 plus 40 is 100. So what's angle B? It's okay. I know you've got other stuff on your mind right now. Okay, 80. So that missing angle is 80. Matt, what's X? 60. Are these guilty of being similar? Every angle of that one matches every angle of that one. They are absolutely similar. We don't know any of the sides. So don't put a reason that has an S in it because we don't know the sides. And then we would need to name the order. So I would say triangle ABC. And you would say that's similar to triangle XYZ. We got lucky this time because it was in alphabetical order. It won't always be in alphabetical order. Next one, go. You have to do math. You can't just put side, side, side because you see 3 sides. You have to do math. You have to do small over small, medium over medium, large over large. Very good. Did they all equal? Did they all come out? Very good. Uh-huh, that's right. Very cute. Name at the top. Yep. Did you not get it? Yeah. That's good math, but what's your answer? So you look at the first triangle, that's good math, but what's your answer? You look at the first triangle and you grab the smallest number. What number is the smallest? 6. Put it over the smallest number. In the second figure. Yeah. Yep. Jeanette, can you tell me what proportion you set up? 6 is to 9, very good. As 8 is to 12. As 10 is to 15. When you reduce all of these, Austin, what number did you come up with every time? 2/3. They all reduce to 2/3. So that's kind of like, well, scale factor's 3/2, not 2/3, but they all reduce to 2/3. So we would say these are guilty of being similar by side, 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 squiggly. If I named the first one, let's name it AMC. If I name the first one AMC, be careful, what would you name the second one? AMC.
D-O-N.
Very good. D-O-N. How did we know? When I named AMC, I went across the smallest, and then I went across the largest. Small and then large. So we need to do the smallest and then the largest. Smallest and then the largest. D-O-N. Dawn. All right, let's move on. Y'all get it. Next one. Choices are angle, angle, side, 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 or none.
Do we have to do the
You do have to check that the sides are proportional. Just because you have sides doesn't mean they're necessarily proportional. Yes, very good. Yes, very good. No, I would mark that wrong on a quiz. Yes, very good. Yes, very good. Uh-huh. You got it. Try again. Very good. Very good. I would still mark that wrong. You're missing something, Kendall. Something really important. You're saying they're congruent, not similar. There we go. Good. Side, angle, side. Side, angle, side. But you have to cover your bases. Does 12 go with 3 as 16 goes with 4? What's 12 divided by 3? 4. What's 16 divided by 4? 4. This is a true statement. So I can say they're guilty by side, angle, side, squiggly. And let's do cow is similar to, this one's easy because they didn't get rotated. Cow is similar to mat. Very good.
It wouldn't be.
Oh, sorry. Oh, that would have been cooler. Yeah, you're right. Y'all are awesome. There we go. Nta. Cow is similar to nta. Uh-oh. There's no numbers.
Yeah, but it says parallel.
It does say parallel. If you were wondering, that's what these bowl arrows mean. Very good, Torian. That means parallel.
Yeah, no, that's all I know.
But that's all I know, so I'm going to stop.
So none. Okay, just put none.
You can put none, but you would be wrong.
Okay, so then I'm gonna do that.
No.
Okay, so then
No.
what's the other one?
No. Okay, guys. Parallel lines. If two lines are parallel, tell me what you know about them. Are they the same length?
Yeah, the one they're double.
No. What do we know about them? Not their length, but their slope. You know their slope. If two lines are parallel, they have the same slope. If two lines are sloping the same amount, then we know something about that angle and that angle.
They're the same.
They're corresponding angles, so they are the same. What about angle A? What's that called? A blank angle. No. Okay. Triangle ADE and triangle ABC. They share something. What do they share? What's overlapping? I'm asking bad questions.
Yeah.
Angle ADE and angle ABC. Where are they overlapping? What are they sharing? Angle A is what I was looking for, but okay. See how they're sharing that angle? That angle A, is in the small triangle and it's in the big triangle. Don't you agree an angle is congruent to itself? It's called a shared angle. Remember when we had these figures last time and we called that a shared side and we put tick marks on it? This is a shared angle. So we've got that angle, we've got that angle. If we wanted to go further, we've actually got this angle too because that's corresponding angles. So the moral of the story is this one is angle, squiggly. Okay. We don't know any of the sides. We don't know them. We don't know the sides. So we're not going to put any answers with the letter S in them.
Okay, so when it looks like that.
When you've got parallel lines, think angles, not sides. Parallel implies angles, not sides. Win and car. Car, win. Right, a guess or an answer. No. People are looking around. Hey, can you solve it, please? Good, Julius, good. That's not one of them. Yes.
I forgot about that one.
Very good, very good.
Well, because I figured like I was doing a cross thingy.
Right. No, yes. Omar, what is this missing angle? Do you know? I don't think it's 38. This is isosceles. So if that's 70, then that's 70. So can you find that one for me? Very good. He's good at mental math. That angle is 40. If that angle was 38, it would totally be side angle, side, side angle, side. But that angle is not 38. The angles don't match. So what do we put as our answer? None. And then what do we put here? When is similar to car?
No.
No. You can't put anything here because they're not even similar. So don't fill that out because they're not similar. Okay. We're almost there. We're almost done. Hot dog. Huh.
Oh, that's right.
Hot dog. Let's go. Who's going to get it? Very good, Matt. Dimitri, what's your answer? Very good. You look suspicious like you just looked at his and then smiled. Okay, I trust you. Yes, no, no. Yes, yes, yes. You got it? You got it? Dimitri, what can I add to my picture? Yep. Yes, you do. Yes, you do. John, what can I add to my picture? You know? I know you weren't in my class for this part. Kenneth, what can I add to my picture? Oh, Catherine, what can I add to my picture? Oh, people. Alea, what can I add to my picture? What? Arcs. Why can I add arcs? What do we have? What are they called? Vertical angles. Does everyone see the vertical angles? We used to do this all the time. Arc, arc. We did this all the time in that unit, the congruent triangles unit, and you just forgot it. All right, look. What's angle T?
90.
What's angle G?
90.
So we've got an angle. What's angle hot? I don't know, it's something, but it's congruent to angle dog. And so we've got another angle, we've got two angles. So the answer to this problem was angle, angle, similarity. Okay. And let's see, does it actually spell hot dog when we do it correctly? H-O-T-D-O-G.
Yeah.
Very good. Okay. In triangle ABC, DE is parallel to BC.
Okay, so it's angle.
But we're not doing that. We're going to find missing sides now. If AC is 30, DE is 12. Oh, this is definitely on your worksheet because I just keyed it. And BC is 20. Find AE. I'm going to let you stare at it, draw it on your whiteboard, and do some work. Oh, you already know it. Okay. No.
No.
You're thinking mid-segment, which is what we
Okay.
learned yesterday. But today, DE is not a mid-segment. It's just a segment. It's not in the middle.
Okay.
So be careful. That's very good. If that problem had been on yesterday's worksheet, you would have put 15.
So that little itty bitty triangle on the top is its own triangle then?
It's its own triangle, yeah.
I don't know.
Set up a proportion, guys. Perfect. Good job, Megan. Oh, set up a proportion. Almost, you're one off.
Yep.
It's an even number, less than 20.
Yeah, but I'm not gonna write that even though I know it's right. It's just gonna-
Good proportion, Ava. Who else can do a good proportion? Blank over blank equals blank over blank. Stop doodling. You can doodle after you get it right. You can't doodle when you haven't even tried the problem. Very good. Yay, perfect. Try again. I'll start you off. 12 is to 20 as, yeah, x is to 30. Look, small triangle is to large triangle as small triangle is to large triangle. Small over large equals small over large. It's not so bad. Try again. Very good. Very good. Very good. Very good. Cross multiply, please. Dimitri, cross multiply. That times that divided by that. Very good.
Gotcha.
Last chance. 18. Very good. The answer is 18. 12 times 30 divided by 20. AE, that was a weird E, is 18. All right, we are at the end of the lesson. Who can summarize for me the 3 ways we can prove triangles similar? Torin, it's yours.
Angle, and then the squiggly.
Angle, angle.
And then side, and the squiggly.
Side, squiggly.
And then side, angle, squiggly.
Side, angle, squiggly. Very good. You have the rest of class to work on your practice. You may work with a partner or a very small group. It is due at the bell. I'm actually giving you enough time this time.